Thanks, guys. Let's get started. Today, we're super excited to welcome Chris Forno. Chris Forno is the co-founder and CTO at Tetmon, which is a company that builds data engineering products. Tetmon, Chris has a wide variety of experience in software engineering. For the past 20 years, he's developed and led teams in distributed systems, computer vision. He's been working in DevOps, cybersecurity, and front-end development as well. He's worked across the US. He's worked at private equity funds, not just tech companies, and he's also worked at Lazada. Impressively, Chris has written several articles and thought leadership within the area of software engineering and data engineering. His GitHub projects have a lot of stars, and he's made YouTube tutorials that have been viewed over 500,000 times. So quite a distinguished software engineer. Super excited to welcome Chris here. Chris is going to be sharing a little bit about the field of data engineering, how data engineering is done at Tetmon and at various companies in the industry, and some about his experiences as well. So without further ado, I'll let Chris take it away for a short presentation, and then we'll open up to Q&A. I will also post the Q&A link for everyone in the chat, so when you have questions, you can pass them there.
Thanks, Kai.
Awesome.
I hope you can hear me.
Yes.
Yeah. All right. Great. Hi, everyone. Just to give a little bit of background, I came here to Singapore. It's been almost 10 years ago, back when Zalora and Lazada forked off, and Zalora was building a data science department. So that's what I came for. Prior to that, I was working in California. At a company that some of you may know. It's called DeviantArt. At the time, it was one of the top 100 websites in the world, and we had a very small team running the whole thing. So anything from writing software tools to running into the server room when the water main above the servers broke and shorted a bunch of the servers and so on. So that was a really interesting, formative time, and it turns out you learn a lot more on the job. In practical terms than you often do in courses and textbooks and so on. I have a few slides to go through sort of on the data side of things. Well, let me see if I can share those first before I talk about them.
Oh, Chris, I think your audio might have disconnected. Oh yeah, we can hear you. Yeah, yes.
Okay, yeah, it disconnects whenever I share a tab. Okay, so hopefully you can see my slides here.
Yes.
Okay, great. So I'm a software engineer first, and then I work on data second, right? And that's a lot of what exists, because sometimes working with the data, you really need to understand the fundamental concepts, the algorithms, how to manipulate the data and so on. So I have some slides, I'll talk about that, but I'm also happy to talk about anything else in sort of data engineering or working with data in general in the field. So in the interest of time, why don't I just start here? Now, I call this a software developer's secret weapon, because not a lot of people learn about this until much later in their careers, and it's sort of like a light bulb goes off. Some never do, but it is. This is the relational model is it's the foundation for a lot of what happens in professional software engineering when you're working with data. Almost every database out there is based on its concepts, but a lot of people miss the foundation. So I just want to talk about this, since this is what I almost always talk about when I'm talking to new developers or someone new to their career. So who's this for, right? Essentially, when you're learning about algorithms, they're always applicable in any software building that you do. And the relational model is probably only 99% applicable. There are certain things that you can build as an engineer that don't involve needing to structure data, right? So you can, if you just want to make art, interactive animations, or you want to make games, certain types of games, then you don't need to worry about data. But this really applies to a lot more than just pure data engineering or a role that has data in the title. Software engineers across the spectrum will end up working with this, whether they know it or not, at some point. And this was invented or discovered or published back in 1969 or 1970 by this guy, Edgar F. Codd, while he was working at IBM. IBM worked on a lot of very large data systems, and he was seeing the same patterns emerge. And he was a mathematician who kind of phrased it formally, this model that he had. He wrote a book. By the way, if you do enjoy math, I know not everybody does. His paper is quite clear, even 50 years on. This paper, a relational model of data for large shared data banks. It sounds a little antiquated, but it's completely applicable nowadays. He also wrote a book that's a little bit more approachable and goes into more examples, called The Relational Model for Database Management. Also recommend that, even though I think it was written in 1980, it's still applicable today. It's still what I would recommend as a first book to anybody getting into data anywhere related to the software engineering field today. So briefly, I won't go into this too much and make this a class, but briefly, what is a relation? And you may have seen this. It looks a lot like a spreadsheet or a table, but it has a very specific mathematical definition. You can go to Wikipedia to learn more. Importantly, there is I won't go into all the mathematical details. You can take a look, or I can answer questions if you're interested. But here's two big misconceptions about this, because you will run into this at some point in the field, especially if you're working on business applications, is you'll have relational databases. Now, they're usually called SQL databases or SQL databases, but they're generally relational databases. On the left is a relation, and on the right is a relationship. And this is a mistake that even some of the biggest, most popular books and people in the data science community make. It's a very easy mistake to make. You see relational, you think relationships, but that's not what it is. It's actually a mathematical term that describes a type of set. Misconception number two is that it's like a spreadsheet. And that's another misconception. There's a very important concept that will make everything you build a lot more robust and predictable and performant if you understand the distinction between these two. And I won't go into it here, but I'd be happy to talk about it more. But if you're curious, just look at the definition of a relation, and I'll give you the hint that it's its uniqueness. So if you're making a table of data in a spreadsheet, you can make duplicate rows, right? Whereas in a relation, you cannot, based on the identity. Now, these are terms you're likely to encounter if you get into data. You may have even heard of them before: SQL, NoSQL, NewSQL. Something interesting is that NewSQL is actually older than SQL, but the name is new. I love these counterintuitive things, so I like sharing this. NoSQL is actually older than SQL. It's a sort of age regression that the industry is going through because they don't want to be responsible adults. They want to just make things work at large scale and throw out the. There is an application for it. I'm not trying to just purely slam NoSQL, but you need to understand the trade-offs when you're looking at a NoSQL solution versus SQL. The SQL has a lot of mathematics behind it that scientists and mathematicians have worked on for decades to iron out all these complex logical problems to keep data in consistent states. And NoSQL says, hey, you know what? We want to build a massive social media site and we don't care about the rest. We're going to throw it all out and go back to the 60s. Again, it has some applications, but you should at least be aware of them. And then the last thing that I recommend, if you're interested in this, is to go through an interactive tutorial. If you haven't already learned SQL or something like it, go to somewhere like SQLbold.com. where you can have an interactive tutorial so that you don't need to get lost in all the steps of installing a database and setting it up and creating the data in the tables and so on. This is a little bit faster way to sort of get your feet wet with writing queries. And queries are really the sort of the meat, the bread and butter of what data roles inside of companies work with, right? So you'll have analysts who are writing queries every day. You have software developers who writing queries can make up a large amount of their time. Either they're writing them in an ORM, which we can talk about, object relational mapping, or they're writing them in a different way, or they're writing them literally in strings. But also designing these tables or designing these relations, it's a foundational activity. And what I've seen between successful systems that get built and unsuccessful ones, oftentimes ones that have a lot of bugs or that fail at large scale or under load, the biggest dividing factor between those is how well the data model was designed up front. It's very difficult to change if you don't get it right in the beginning. But if you get the data model right, the code sort of naturally flows from it. It sort of dictates it gives you a path that you have to follow. So, so hopefully this is sort of whet your appetite to go learn more. I'm happy to talk about any of these concepts, or more generally outside of the relational model, even though I think the relational model is 80% of what you'll deal with in data in a professional context. I'm happy to talk about other aspects of data like data cleaning, any of the data science topics, stuff like that. So Kai, I guess back to you. That's my intro.
Awesome. Thanks so much, Chris. Great. So I'm just gonna dig a little bit into Chris's experience in this space. If anyone has any questions on Chris's presentation so far, please post it in the Q&A link. Let me just see. Yeah, please post in the Q&A link in the chat. I will just resend that again in case anyone who recently joined hasn't seen it. Chris, yeah, I have a couple. I mean, there are a few more topics that I would like to dig into.
Sure.
And I'm just thinking in my head now, where should I start? I wanted to discuss a little bit about data engineering. I wanted the different areas of data engineering, and because relational databases are, our students go through SQL in our course. They use Postgres, build relational databases for their applications. They don't have that much exposure to NoSQL, so it could be interesting to learn a bit about that. But maybe we can start here. Maybe more broadly, when we talk about data engineering, right? We know that software engineers in general use SQL. Most software engineers will, or some kind of, they need to engage with some database, right? Whether it's SQL and like Postgres or MySQL, or NoSQL like MongoDB. But then what's the point of having a specialist role called data engineer? Like, what do they do? Is that different from software engineering? What is their role?
Sure. So I guess you can think of data engineers increasingly, the way I think of them is as sort of the inventory, right? So as software engineering gets more specialized, the senior software engineers want to pass off the stuff they don't want to do. And oftentimes that goes to data engineers, because so much of the value of software to companies is the data that it collects or generates or creates, right? And increasingly, when beyond the basic role of a system, right? Like, let's say you're running a website. I have a lot of experience in e-commerce. So you're running an e-commerce site. The core function is that you have to accept payments, and ship products, right? Send the orders to the warehouse and everything else. You need to keep the system running, and that's a baseline. But everything beyond that is usually a data request, right? So executives need reporting. They may want dashboards, all kinds of analysis. But even beyond that, the core data, there's supplemental data, right? You have telemetry data, which is how the system is performing. So the system will usually be instrumented with a lot of tracing logic that will time how long things take and structure this data and push it out to another application that people will go through. And that application may be queried through SQL itself. The data engineers will often get a lot of these odd jobs. If, for example, developers have set up a new feature and they want to migrate the data over to it, right? It's a different structure or a different version or so on. The data engineer may be tasked with writing a migration script. That's one. Very often data engineers are working for a BI or data science department to clean the data for them. There's a saying that 90% of data science is actually data cleaning. I think it's higher than that. And it's also, yeah, it's also data sourcing and everything else. Increasingly, the fancy, sexy parts of data science have all been automated with tools, because computing power is cheap enough that you can throw sort of a random forest algorithm at something that can automatically select the best performing data science algorithms. But what's important is making sure the data is clean, making sure that you're augmenting the data with as much external or extra data that you can, because data science succeeds or fails based on the quality of the data, period, not the algorithms. The algorithms make very little difference. I mean, for certain things like machine learning, vision, so on, the algorithms is important. But for most data science that you're going to see in like a normal business context, which is regressions, linear regression, right, which is fitting a curve to some data, or support vector machines, or any of these things which find coefficients of a model, right? So it's solving some equation the best as possible to build a predictive model. Any of these applications, the data quality outranks everything else. And so data engineers always get involved. I always say that data engineering takes a certain type of personality, somebody who's detail oriented, somebody who's a little bit of a perfectionist, who gets annoyed and can feel when the data is not clean. Those make excellent data engineers. Even more important than the skills that you have, because the skills you can learn. And in fact, you can clean data and engineer data in many different ways, using all kinds of different tools, different techniques, different algorithms. The most important part is thinking about the data and caring about the data. So yeah, I don't want to make that answer any longer than it already is.
Yeah, that was great. So yeah, data engineering is a lot about cleaning the data, about managing the data so that we can perform analytics on it. In Rocket Academy's bootcamp, we mostly do app building. So we build applications and we also practice algorithms. And for someone who might be keen, who might be detail oriented, like you mentioned, and is keen on getting into this area of data engineering, how would you recommend we do that?
Sure. Yeah. So if you're interested in it, I mean, first of all, get the concept of SQL down well. Now, some people will, if you really get into the relational model, some people will complain about SQL because it compromises on some mathematical elegance and so on. But effectively, SQL is king right now in the industry, and it has been for 50 years, ever since it came on the scene, because it's such an effective way to not just store data, but to make sure it remains consistent and that you don't get problems, especially in something like the finance space. You just cannot afford to have data go missing or have data anomalies and so on. So SQL is the foundation in the current market. So I mentioned SQL Bolt. There's other sort of interactive sort of, and whatever else you're learning at Rocket Academy and so on, but you really need to go into practical applications. From there, you know, if you are building your own applications, just practicing with a database is important. But I'd say that the best thing to do is learn from well-engineered databases out there, because it takes time to understand why you would put in the effort to design a data model or any of this other work. So that's for if you're a software engineer who wants to do some data engineering. Now, if you want to go purely into data engineering, the skills you've already learned are probably sufficient, because data engineering is usually seen as sort of an entry level thing where, like I said, it's a lot of the software engineers don't want to do that type of work because it can be mundane or it's just not sexy. And just being able to you will need to have some tools that you can rely on. So for some people, that's if they like Python, it's Python pandas, or it's another one of the Python libraries for managing data frames. I would recommend, actually, oftentimes the only tool you need is a SQL database, and you can do everything you want through SQL queries. There's also R, which is if you're more on the mathematics or statistics side of things, or almost any general programming language. If you know the fundamentals and you study a little bit of the relational model or NoSQL, that's enough to get started in the industry and start learning. Depends on the company. Some companies will be very particular about what they're hiring for, what they're looking for. They might ask certain sort of tricky questions and so on. But from what I've seen in my own experience, there's always a shortage of data engineers who care and who have the right sort of approach to it. So don't know how helpful that is, but
yeah, that's great. It gives us a sense of what the data engineering work is. How about Tetmon specifically? So I know Tetmon builds a product to help companies manage their data. I'm not sure about the specifics, but I would love to hear what kind of data engineering work or engineering work in general is done at Tetmon.
Yeah, Tetmon, it's interesting because we formed out of a data engineering, data science services company. We now build a product. The product is a SQL interface to disparate data sources, right? So databases or Google Sheets or Excel or CSV files on Amazon S3 or something like that. So we're seeing a shift in the industry away from traditional data warehouses. So with the traditional data warehouse, you have your data sources. You either have change capture, where you're capturing the changes as they happen, or you have batch processing, where you're pulling all the data out of your data sources and you're running an ETL process on them before you put them into a data warehouse, right? And that's how things have gone on for a long time.
Not everyone here knows what ETL is, so it might be worth just sharing.
Sure. So ETL stands for extract, transform, and load. So you extract the data, you transform it in some way, and then you load it into the data warehouse. Now, the ETL is very broad definition. It can be any tool, it can be any transformation process. Sometimes there's no transformation at all. ETL just means select from one, insert into another. It can be, most frequently, it is pre-aggregation. So that means that you're taking some raw data and you're aggregating it along some dimension like time. So in the e-commerce example, you're going to be aggregating total revenue per day and per week and per month and so on. These aggregations are usually done so that the data is quicker to work with inside of the data warehouse. And the ETL process, just the ETL process in even medium-sized companies can be a full team of engineers, just depending on how complex all the different data sources are.
I used to work on the ETL team when I was in the US.
Oh, yeah?
And we had a team of engineers working on it.
Yeah. It's one of those things where I mean, Kai, you have to get it right. It has to run reliably. If it goes down, it affects everybody who's consuming the data. And the most important thing is that if it breaks in a non-obvious way, it can steer the whole company in the wrong direction. So there will usually be a team servicing requests and making a lot of changes, either in a visual workflow tool or sometimes as Python scripts or something else. Yeah.
And so Tetmon's product is helps people build ETL?
So Tetmon's product sort of removes that, and instead you go in, you enter the database details, and when you write a SQL query, our product breaks that query down and comes up with a query plan that that runs queries or extracts data from the data sources at query time. So it's often called a virtual database. Others exist out there. It's been, I think it's been around. The concept has been around for maybe 5-10 years. That sort of eliminates ETL, or I'd say what it does is it makes the E and the L sort of automated, and then the T shifts from a Python script or something else into a SQL query or a view, right? So when you're working with a SQL database, I don't know if you've been exposed to views in your coursework, but often you'll write a query and then you can save that query as a view. And so that query appears as another table or another relation, if you will use the math term. And so that's one way, that's really the only way of abstraction inside of SQL, right? So you learn about abstraction when you're building algorithms, and then the foundation of abstraction is a function, or in some cases an object, right? And on the data side, the basis of abstraction is a view for SQL. So you can build a view, and then another view can build off of that view. So our product takes the approach of we automate the extraction and the loading, and then everything gets put into views for doing the transform.
And okay, that was helpful. For those of us who might be keen on working more with data, is every company hiring data engineers, or should we be looking at specific kinds of companies? If most of the work is ETL, it probably requires some large amount of data to have data-specific engineers. I'm curious to hear your thoughts on the different options in the industry for data engineering.
Sure. Yeah, I'd say any sufficiently large, business tech company or any large company will have it, and then any sort of medium-sized tech company will have the need for it, I'd say. Now, it depends on what your definition of medium-sized is. I think the only tech companies that are not in need of data engineers tend to be video game companies. If they are just producing sort of single-player games, not if they're hosting. If they're hosting, then they probably need data engineers, right? If it's a multiplayer or online game. Other than that, I'd say almost every company needs them. Now, whether they're hiring for them or not, depends. It depends on a few things. If the engineering team is very strong, if the data sources are all very regular and they come from clean places, like, for example, a small e-commerce site may have very clean data because it's all entered by customers and everything else. But other than that, I'd say pretty much any company has the need, and probably many of them are hiring for it.
Nice.
Now, even if they're not hiring specifically for data engineering, if they're hiring for data science, if they're hiring for AI, if they're hiring for machine learning, they will be putting somebody in the role of data engineer, even if it's not listed in the job title.
Right, it might just be the job might just be a software engineer, and they're already just doing data engineering, right?
Exactly.
Yeah.
Or the job might be data scientist, and they're doing data engineering, which is quite often the case.
Yeah. And the common denominator is software engineering. They need those skills to be able to write scripts and functions and programs.
Because SQL, the way that I think about SQL is that SQL is a restricted programming language, right? There's the only inputs are relations or tables. The only outputs are relations or tables. But it is the type of programming language. If you work with PostgreSQL, there's the idea of recursion is in there. Looping, a lot of them are implicit. It's declarative, but all the same concepts are there. So that's why it really is an engineering role, even if it's just writing queries all day. still an engineering role. You still think like an engineer. You still need to understand the algorithms, even if you're not writing algorithms. The understanding of algorithms helps understand why a certain query produces a certain result, or why it's very fast instead of very slow.
Nice. Okay. I would like to solicit questions from the group because you guys are quite quiet, both in here and on the chat. What areas would you like us to dig deeper into? Everyone's just gone out of class, so they're zoned out.
I see a few questions showing up on the Pigeonhole board.
Okay, quick question from Justin. Are there good examples of good database designs that are available publicly that you would recommend?
Yeah, that's a good question. I wish somebody compiled those, or I wish I had myself. What I would look for is database diagrams for open source projects. I'm not claiming that they're the best, but they're probably the only ones you're going to find published, because any data diagrams inside of a business are tightly guarded as a sort of, not as a trade secret, but just, it's not something that they're going to publish. So if you're interested in e-commerce, for example, this is a field I keep going back to because I have experience with it. You can look at the big systems like Magento and so on. The guys have published database diagrams. They're not perfect. Every software system has grown a lot of cruft and everything on the edges, but they're often well studied. Another one you can do is you can go look at, for example, Wikipedia's database backing it. How does that work? Yep. Or any of the larger open source projects. I don't know if Stack Overflow publishes the code, but something like Discourse or a lot of these larger projects will have, at some point they'll get documentation on how their whole data model works, and that would be a good thing to study. But be warned that it's very large. The book, it's often hard to understand some data models unless you also understand the code. But a well-designed data model should be understandable on its own. Of course, Cod, the guy who came up with relational databases and the book I mentioned, does go through some smaller toy examples, and of course I think they're excellent examples of sort of the concepts that you may not see if you're just looking at a big database system out there. You may not see why certain primary keys were chosen and why certain things were done. And I think the books will sort of explain those concepts. So that's where I'd start.
Oh, that was really comprehensive. Justin, does that answer your question?
Yeah, it does. Thank you.
Awesome. Thanks, Justin. Mike had a question around positioning. Mike mentioned that, Chris, you mentioned you were a software engineer first and a data engineer second. Why do we make a distinction between software engineer and data engineer? Is it an advantage to position ourselves as either a software engineer or a data engineer, software engineer with experience in data science? How should we position ourselves as software engineers that can work with data?
So the reason I think of myself as a software engineer is that once you've had enough exposure to this, data engineering and software engineering, the line between them gets quite blurry, because most development, there's a certain number of algorithms, and you will learn most algorithms at some point, right? There's a lot of algorithms in the art of computer science and some of these encyclopedias of algorithms, but you will never have the need to apply them, right? Certain algorithms will show up over and over in your programming, and those algorithms eventually get abstracted into libraries or features of the language. And increasingly, what I've noticed over time is that software engineering, the software engineering that I do, I'm always thinking about the data. Data engineer as a title is generally seems to be applied to people who are cleaning or adding features to, or finding finding, aspects of data out. It's usually applied to ETL type roles or these type of, scripting tasks and so on. So that's why. So if you want to position yourself, I mean, there's an advantage to positioning yourself as a data engineer, right? Anything that you do that makes you more specific increases your hireability and possibly the salary that you could command, because you're a specialist, right? That said, it can be considered that the data engineering is more of a junior or commodity role, so it may not give you the same sort of salary as like a full stack developer, right? And so now, as far as an advantage with being a software engineer with experience in data, yeah, I think any of your exposure to data engineering, data science, all that will actually translate quite well into your software engineering. It will change the way that you write programs. Definitely.
Why is that?
I guess it gives it, this, I've heard this anecdote that these master chess players, they can look at a chessboard and instantly know what's going on with it, right? They know who's in an advantageous position. They know how this game has played out roughly to this point, and they can remember the positions of everything on the board very quickly. Whereas, we look at it, if we're not master chess players, we look at it and we have to like individually look at all the pieces, and there's no framework in our mind that we can quickly hang everything on. Yeah. The more you work with data over time, and the more you work with the mathematical concepts that are underneath it, the more you're able to generalize the data that you're working with and fit it into something. And a lot of software engineering is combining algorithms with data structures. So I think of most software engineering as having two types of data structures that are used 90+% of the time. One is a tree, and the other is a relation or table or something like it. Now, when you're going through and learning about algorithms, you're going to learn about lists, linked lists, arrays, all these kind of things, right? And you may look at some like really fancy data structures like red-black trees and tries and all this other kind of stuff, and you may have some chance to use those at some point in your career. But in general, if data is hierarchical, it's going to be some type of tree, and if it's not hierarchical, it's usually going to be in a relational format. And once you've seen fitting data into those, then you can focus on the algorithms. And once you know the data algorithms, the algorithm abstractions and the data structure abstractions, then programming is more of just kind of combining and getting things to flow from input to output, rather than worrying at the individual level of the chess pieces what to do with it.
That's helpful. Cool. Thanks, Chris. Dewi had a question about specific dialects of SQL. We just learned PostgreSQL. We choose PostgreSQL at Rocket Academy. What do you think of MySQL and Oracle? Which one do you prefer? I think MySQL is owned by Oracle, right? If I'm not wrong. So
yes, they ended up purchasing it.
Okay.
Yes. So,
yeah.
but they are three distinct databases. I love PostgreSQL. I think it's that they have a very rigorous development process, and they always prioritize correctness over features and performance. And so for a long time, they were behind because of that. But now they seem to be ahead, even in a lot of the performance areas as well, right? Because once you get the system performing correctly and you have a rigorous process in place, then you can start making optimizations without worrying about how you're going to break things. So I use PostgreSQL for a lot. I have a lot of experience with MySQL, and MySQL has its advantages. So there's historical MySQL, which used MySAM as the engine, and I think that's inferior in most ways. There's modern MySQL, which uses InnoDB as the engine, And that is much closer to PostgreSQL. InnoDB was developed heavily by some guys inside of Facebook that Facebook hired when Sun, I think, was being bought over, and they were getting the MySQL guys, because I think Sun bought MySQL before Oracle did. So MySQL has some advantages, but in general, I think unless you really know what those are, and they're very narrow advantages, I would go with PostgreSQL. There's less surprises. Things are just generally more correct, and the performance is on par. The one major advantage that MySQL has, even up until recently, is that replication is better. So replication is when you have data that's inserted into one database being automatically copied into another database, right? Usually within seconds or less than a second. And the reason for doing this is that as you scale up a service, as it comes under more load, eventually you're going to have too much load for a single server, right? This is when you hit the point where, if you're processing thousands of queries per second, eventually a single server may have an issue. Now, servers have gotten a lot better, especially with SSDs. I think you're all familiar with SSDs. And also, beyond SSDs, you can get 1 million, 2 million IOPS, the IO operations per second. So I'm getting into a little bit of the operations and the DevOps side. But essentially, you can scale a single database only so far. Now, most companies will only need a single database if they structure it well and optimize their queries. But if you're at Facebook size or something else like that, right, you need replication, and that's where MySQL has historically been stronger. In terms of Oracle, in the past, I'd say in the 80s and 90s, Oracle had advantages, but PostgreSQL has made up all or almost all of that ground and then exceeded them in many ways. I can't imagine. I mean, Oracle, from what I understand, if you're willing to pay the licensing on it, there's a lot of documentation and the performance should be pretty good. But you're usually going to see it in legacy systems and very large companies only. And I just don't have enough experience with it.
Who is maintaining Postgres?
It is a group. You can actually meet most of the PostgreSQL maintainers once conferences, once you can get to international conferences again. The guys are very approachable. They show up at at some of the database conferences. I've met a number of them, and usually what it is they are employed by consultancies that position themselves as experts and want to have influence over the development of it. There are some university staff that are contributors and so on, but the core is pretty small. At least when I worked with them, it was less than 10 guys. Yeah, and so it's like Linux, right? You have a broad base of contributors, and then you have a sort of a number of generals that are sort of processing their areas of expertise and making sure that the contributors are sending in something that follows the sort of the guidelines and so on. The difference between Linux development and Postgres, I don't think you have like a single guy at the top like Linus. So,
got it.
Or Linux.
Yeah, well, actually, the person named it after himself, right? There's some new questions in the thing. Okay, Brian had a question specifically for bootcamp students. Do you have any recommendations for a learning roadmap post-graduation? Maybe not even just within data engineering. How would we continue to grow even after we start working?
Yeah, I think so. So when I started making YouTube videos about software development, I thought there was a shortage of. I think there's a problem in our industry that people don't read, specifically code. They don't read other people's code and learn from it, right? We read books, we watch videos, and so on. So I often like anybody who's doing any coding on camera. Increasingly, you can find these people on Twitch even writing code on camera. I'm not sure they're the best, right? Like a lot of these game developers are self-taught. They've been working not on a team for years and years. But you can learn something. If you can find anything that's interactive, that's best. But I know those resources are pretty few. But I'd say try not to get too focused on algorithms. I know that Google specifically really pushed the industry in that direction for a long time. And for Google, it's important, right? Because everything for them is latency. They have to deliver things as quickly as possible. So they had this real focus on algorithms, and all these companies were copying their interviewing style. And so a whole generation of engineers got obsessed with algorithms. They're important, but I'd say just avoid going too far down into algorithms and work more on whatever you're interested in. Really, I could give more specific recommendations if you want to be a front end web developer or something else like that. But in general, I don't really have any good general recommendations. Sorry.
Brian, do you have any follow-ups to that? What were there any particular areas you were thinking about? Oh, I think you're muted. Or the sound's not
Okay.
good. Oh yeah.
Yeah.
Yes.
I was just asking, because in the context of us just graduating, and we're all gonna get our individual jobs, but then I was wondering if there was like a way that we could set a direction and continue what's important in the industry, or how do you view the tech industry is moving towards where we can actually better position ourselves as software engineers for the future and not just for the present.
Yeah, and this is Mike's question as well, so good dovetail. Yeah,
that's a good question. All I can say with confidence is to tie your learning to what you're doing, because if you're learning abstract concepts, if you're just trying to learn a concept, I don't know how well it sticks. For me personally, I've learned the most always trying to solve a problem I'm working on. And that problem, just like looking at it and looking around on what people are discussing, will reveal a lot of topics that I can study about more, but always in the service of solving a problem. So if you're in a job, I think just paying attention to what you're doing, you're going to have plenty of motivation to branch out from there. And then, but if you're not in a job yet and you're going through, the interviewing phase, I mean, obviously having a personal project, if you have the time for it, would be the best. Something that interests you, and you'll find plenty. And there's so much information available. You'll have no problem. You'll find the style of book or video that works for you, I think.
That's very awesome. I had we touched on this briefly earlier when we were talking about Postgres and the dialects. That was actually really insightful. You were talking about I can't remember in what context it came out. We mentioned DevOps, and I realized we hadn't talked about that. So DevOps, people know about DevOps as this, it's kind of this DevOps and security, right? It's a bit of this kind of niche and sometimes sexy part of software engineering that, but I guess maybe didn't used to be, but now it's more sexy because those people get paid a lot. What should we know as bootcamp and graduates or general software engineers coming in at entry-level software engineers? How much do we need to know about DevOps? How much is specific to data engineering? How much should we know as a general engineer?
Yeah, I think that also ties into Mike's question as well about where the tech world is going and what you need to know to be relevant. And the reason I say that ties in is because from where I see this sort of thinking about systems on a larger scale is becoming increasingly important, and building individual programs is less. I think decades back, writing a program was a large amount of the work, and now there's so much open source systems available. A lot of the work is connecting things together. Now, there was this vision of a glorious future for software engineers where objects are reusable and everything has this well-typed interface and they can all plug together like Legos. It never happened. But I think being aware of which systems solve which problems well. I mean, obviously Postgres is an important one for data, but also for other things. Knowing these systems and knowing the connectivity between them is important. And this is a lot of where DevOps is, right? So you can think of DevOps either as the very strict definition of the code building and deployment pipeline, or you can think of it more as a developer who's working at a higher level than an individual system. And that's how I think of DevOps. So once you can move up and connect things together, that makes you very valuable in the company. And I don't know if it's always the case, but generally DevOps should be commanding a higher salary. I know it's always in demand. It's always in demand. You can find almost every tech company here in Singapore needs more DevOps. That's how it feels to me, at least the ones I come into contact with.
Yeah.
Yeah. So I'd say two things, right? That's sort of a long-term goal. Don't try and learn out all the systems out there and everything else. In the short term, be specialized, right? So if you know PostgreSQL really well, that will make you quite valuable. Or if you know how the browser and the DOM works, or you know CSS very well, or something like that, those skills will be valuable. If you're a generalist and an inexperienced generalist, you can still find work, right? This industry is very hot, but I think it's harder to really stand out. And even once you're in the job, it's harder to add value when you don't have a specialty. So potential specialties, like I said, PostgreSQL, really understanding the browser and the DOM and the JavaScript execution model and the CSS and all this. This is all very important. Front end, almost everything has a web front end nowadays. The areas that I think are less important are really the performance, the esoteric algorithms and so on. I know I've downplayed them before, but knowing knowing all the sort of it used to be popular, these patterns, the patterns movement, and knowing all these different patterns and so on, I think is not as useful as knowing a specific tech to solve a specific problem well.
That's really helpful. And so DevOps, when I think of DevOps, I think a lot of the cloud providers, right? AWS, GCP, have to mention all of them, Azure, Alibaba Cloud, right? So many different ones.
Yeah.
IBM has one. How much of those cloud systems should we try and familiarize ourselves? Or should we just go with that problem-based approach that you were mentioning earlier?
Yeah, I think I tend to think of a few services that all of the platforms have in common as a foundation that you should probably know about, right? So the AWS is EC2, and then all the equivalents, right? Which gives you a virtual machine to operate with. Then object storage, right? So this is S3 on AWS, and all the others have an equivalent. I mean, these are the two cores. This is what Amazon launched with in the beginning. Everything else is sort of, you can build everything out of those two, right? I mean, technically you can build everything out of EC2, just a bunch of virtual machines, but the object storage is actually a useful abstraction. It's very applicable. The other things tend to be sort of automated services that will depend on the problem domain that you're going after, right? Like, so RDS, well, that's just a managed database that's effectively an EC2 instance. They're just managing the installation for you. A lot of these services, Route 53, that's DNS. You may never work with DNS. It may be very important to you to know how DNS works. At a higher level, though, I would recommend, essentially, because you are software engineers, you have the skills to learn some abstraction. So what's very popular is a tool like Terraform. I think there are other tools out there like Pulumi, or specific to the cloud platform. There's one that AWS puts out. But all of these systems have APIs, and so get out of the web interface and be working with either the command line tools or the APIs, some way that you can actually abstract do that as soon as possible. Now, obviously, in the beginning, you're going to have to work in the web console to kind of understand how everything is working. But the sooner you can sort of abstract, the more useful it is if you want to specialize in DevOps.
The web console of like AWS, for example. I mean, get into the automation and the abstraction of working with those services through the command line. Okay.
Yeah. So with AWS, the first step to getting operating at a higher level, if you're really going into DevOps and want to manage large networks of services, is, for example, CloudFormation, right? You design a template of how something gets deployed and you apply that. So instead of clicking through everything, those skills are in very large demand.
That was very insightful. Do we have any other questions from the group? That was super insightful, Chris. Maybe just one final question before we wrap up. Would you have any parting advice for the group who are becoming software engineers for the first time?
It just goes back to the slides at the beginning. Don't underestimate the data. Take a little bit of time to understand the mathematics behind things. I don't know everybody individually how they feel about math, but sometimes just learning these concepts to have something to hang things on in your mind helps a lot. And this one, I think, is the biggest bang for your buck in the software world. And so that's my advice. It really is. It really does. It will, if you do master it, it will feel like a secret superpower. Sorry.
Yeah. Awesome. Chris, I learned so much today.
I have one last question.
Oh, go on, Mike.
Is that okay?
Please, yeah.
My mic was on mute. I was talking, and then anyway.
Okay.
What's your tech stack nowadays? What do you use every day?
So personally, I write most general code in Haskell. So I'm a big functional programming guy. If you have an interest in going that way, it has a very steep learning curve, but if you want to get to a high level of abstraction and do more with less code, that's where I would go. As far as the full stack, JavaScript for anything, TypeScript. If you do any work in the browser, use TypeScript. Do not use JavaScript. Don't waste your time. TypeScript is strictly better on every metric because it's just a superset of JavaScript that prevents a lot of silly errors. So use TypeScript if you do any web browser stuff. So TypeScript, Haskell, PostgreSQL, Linux, those are my go-to tools for almost everything.
All right. Thanks, everyone.